Good morning, students. Today we will discuss inverse trigonometric functions. In our earlier classes, we have discussed about trigonometric functions. Now, we are going to discuss the inverse of those trigonometric functions. We also discussed in our earlier classes about functions, inverse of a function. Now, as trigonometric functions exist with domain and range, we are going to see how that inverse of those trigonometric functions behaves and different formulas related to it. If you see the word in the entire statement, inverse trigonometric functions, the word inverse is there. Now, when the inverse of a function exists, let's recap from our discussion in the function. So, if f is a function from a to b, we know the inverse of this function exists if f is 1, 1 and f is on 2. That means f is injective and surjective, or in short we can tell if f is bijective, then inverse of f exists. So what is the meaning of 1, 1? F is 1, 1. That means what? That is for x1, x2 belongs to A and x1 not equal to x2 implies fx1 is not equal to fx2. That is the definition of a function, that is the definition of a 1, 1 function. And what is onto? If f is onto, that is for all y belongs to B, the codomain set, there exists x belongs to A, the domain set, such that y equal to fx. If these two property holds true, then we can say a function is invertible or the inverse of a function exists. Now let us see whether these trigonometric functions are actually being satisfied by means of these two properties with respect to their defined domain and range. Alright, let's see what is the behavior of sine. If we see the function sine, what is the domain of this function sine? Domain is actually R, the set of real numbers. And what is the range? Range is the closed interval -1 to 1. That means any real number between -1 to +1, including -1 and +1. That is the range of sine, and that is the domain of sine is the real number. But is the function sine is 1, 1 and 1, 2 with respect to this domain and range? Let's see. We know one thing, that is called the trigonometric functions are periodic in nature. That means after a certain period, in this case it is angle, the value of this trigonometric function repeats. Let's see by means of an example with sine. If we see in the sine curve, so this is origin, this is positive direction of x-axis, this is negative direction of x-axis, this is positive direction of y-axis, and this is negative direction of y-axis. Let us take the measurement along the x-axis with an interval of pi by 2. Then it becomes pi by 2, it's become pi, it is become 3 pi by 2, this is, can write in top, this is 2 pi. Similarly here it is minus pi by 2, it is minus pi, it is minus 3 pi by 2, and it is minus 2 pi. Now what is the sine curve? And before that, let's take, this is plus 1 along the y-axis, this is plus 1 and this is minus 1. Now let us draw the sine curve. How the sine curve looks like this. Like this. And in the negative direction of the x-axis we get like this. So this is the maximum value 1 at pi by 2 and the minimum value minus 1 at minus pi by 2. Now if you see two angles 0 and pi, 0 and pi, though 0 and pi are two different values, but the sine of 0 and sine of pi are equal and both are equal to 0, right? So we see that 1 condition is actually not holding true. That means 0 and pi, if we take x1 as 0 and x2 as pi, then x1 is not equal to x2. But sine x1, that is sine 0, is 0, and sine x2, that is sine pi, is equal to 0. So both are equal where the 0 and pi are not equal. So what we see here is that 1 is not holding true for the function sine in their defined range and in their defined domain and range, the function sine is not 1, and as it is not 1, there is no question the function is invertible. So what we see, the function sine is not invertible in the defined domain and range, and the similar thing is true for the other trigonometric functions like cos, tan, cot, sec and cosec. Now before that, let us see what is the defined domain and range of these trigonometric functions. Okay, we have discussed in our earlier classes in trigonometric functions, but let's have a quick recap. So if we see the trigonometric functions and their domain and range, for the function sine, we just see the domain is the set of real numbers and range is the closed interval -1 to 1. The similar thing is true for cos. The domain is the set of real numbers minus real numbers, and the range is the closed interval -1 to 1. The function tan, the domain of the function tan is the set of real numbers excluding few angles though x such that x x equal to 2n plus 1 into pi by 2, where n belongs to z, the set of integers. That is the domain of the function tan, right? That is the set of real number minus the value of these angles, which is multiple of 2n plus 1, where n is belongs to z. And the range of this function tan is the set of real number. What is the domain of the function cot? Domain of the function cot is R minus the set which is a multiple of n pi, x equal to n into pi, where n belongs to z, and its range is the same like tan, which is R. Then it is coming sec. The domain of sec is just like tan, that is R minus x such that x equal to 2n plus 1 into pi by 2, n belongs to z. This is 2. And what is the range of the function sec? Range of the function sec is that it is a set of real number excluding the open interval minus 1 to 1. Open interval, that means it excludes minus 1 and 1. The cosec has the domain same as cot, that is R minus x such that x equal to n pi and n belongs to z, and the range is same like sec, that is R minus 1 to 1. Now the point is, what we see here, that in this defined domain and range, these are the defined domain and range for the trigonometric functions. Now in this defined domain, the function is, none of these functions is 1, 1. Neither sine, not sine, cos, tan, cot, sec and cosec, none of these functions are 1, 1 in this defined domain. And as this is not 1, 1, these functions are not 1, 1, there is no question these functions are invertible. So the question is, how we can make these functions invertible? That is the part of the discussion in our second session. Thank you.